All right, so what this lesson is on is how to plot points in polar, so polar coordinates. Now, it's probably never been mentioned to you. We just say like plot something because you've never had any plane other than the XY plane. And I kind of have this scratch sheet here just I'm going to use to like explain things. You don't have to write this part down. I'm just going to use this to do my explanation. But you know how you've done this and you have the X-axis and the Y-axis and you plot points and it's X comma Y. Give me numbers. I'll just make an example. Yeah, like 7 comma, make something -4. Okay, so 7, -4, you would go 7 on the X-axis and then down 4 on the Y-axis, and like that's your point, okay? No one has probably ever mentioned to you what this is called because it's the only one you've ever used, but this is called rectangular. These are rectangular coordinates, which kind of makes sense because when you go over and down, do you see how it makes like a rectangle? Following me there? Okay. What we're going to do today are polar coordinates, and it uses the unit circle. So instead of X comma Y, it's R comma theta. R is the distance from the origin that you are, and theta is how far you've rotated. So for example, let's say we put a point like right here. If you connect that point to the origin, this distance is R, and it's like R stands for radius. Like if you went the whole way around, it would be a circle. We've talked about this when we went over the unit circle. That distance is R, and how far you've rotated is theta. So it's just a different way of finding the point. It's R comma theta. And the origin is called the pole, kind of like the North Pole or the South Pole. The origin is called the pole, and it is 0 comma theta, where theta is any angle, which is kind of interesting. But no matter how far you rotate, it could be like 1,000,000 pi. If R is 0, you're on the origin. Does this make sense? Like that would be the pole. Okay, so on the front of this sheet, we're just going to practice plotting these, but I'm gonna go over to my scratch sheet just to like explain something to you real quick. And again, you don't have to write this part down, but I want you to watch so you understand, because there are an infinite different ways, an infinite number of ways that you can name these points, because you know how you have coterminal angles and you can keep going around, or you could go backwards. All right, so there are an infinite number of ways you can name them. So I just want to do an example. Say, for example, you have 5 comma pi over 4. And again, just watch. I want to show you how this will turn out. And this is my personal thing. I really wish it was the other way around. I really wish it was theta comma r, because you have to rotate first and then go the distance r. I don't really understand why it's r theta. No one asked me my opinion. But anyway, you would rotate to pi over 4, which let me just like dot this in. Do you see how this would be an amount pi over 4? I didn't get out a protractor, but are you going with me on that? So you would rotate to pi over 4, and then you would go 5 units away from the origin. So that would be that point. Do you follow me there? But you could rotate the opposite direction and still end up there. So it could also be 5 comma negative what? And instead you rotate around this way. How could you still end up there? -7 pi over 4, and you would still end up at that same point. Okay, or, but wait, I'm not done. Or you could rotate to here. If you rotate down to here, like straight across from it, how far did you go? 5 pi over 4. And if you go backwards 5, so it could be -5 comma 5 pi over 4. So you would go here and then go the opposite direction. Or if you rotate backwards this much, that would be negative how much to get to here? It would be -3 pi over 4. And then if you go backwards 5, every single one of these is this point right here. Let me show you another one. And there are more. There's an infinite number, because you could just keep rotating around, keep adding on 2 pi and keep landing in the same place. There's an infinite number of ways you can talk about the same point, which is both cool and frustrating in equal parts. Do you know what I'm saying? Like, it's fascinating, but it's also like, dang, can't we just have one name for everything? Go ahead. See, if you rotate backwards 7 pi over 4, so you start here and you go backwards 7 pi over 4, that puts you right here. And if you go 5 units away from the pole, that's going to be that point. You've just gotten there by going backwards. Yeah, here, let me do one that's in the, well, here, pick a different quadrant other than the first one, and I'll make up an example that's there. The third quadrant. Okay, so say you had, and I'll stick with 5. Let's say we had 5, 7 pi over 6. So if you rotate 7 pi over 6, that's going to put you in the third quadrant. That's going to be like right there. And if you go 5 in that direction, there's your point. But let's say you rotated backwards. It could also be 5 comma what? How could you get to the same place just going backwards? It would be negative how much pi? Negative 5 pi over 6. That means the exact same thing. Or you could rotate to here and then go backwards 5. So it could be negative 5. How far did you go if you're here? Pi over 6. Or it could be negative 5. And how could you get here by going backwards? How much did you rotate to get there if you went backwards? It would be negative. Negative how much? 11 pi over 6. And those all mean this point right here. Again, it's like equal points cool and frustrating. Like it's neat that you can do that, but it's also like, oh, those all mean the same thing. Okay, so here's what we're gonna do. We're gonna take these and plot them. We'll label them A, B, C, D, E. I'm gonna do this one time, put the phone away. And if you're frustrated, that's fine. It's only gonna take like 2 minutes, but I'm not gonna label them again. It'll help you if you have this labeled at least one time though. Whenever you see this polar coordinate plane, these are counted in 12ths. The reason they count by 12ths is everything on the unit circle could go into 12ths. So this first line that you see here is pi over 12. That's 1/12. And we're gonna count by 12ths. And again, it's just like filling out a unit circle. Humor me, I'm gonna do it one time because I know some people it'll help you and I want it to help everybody, right? So that's 1/12. The next one's 2/12. That'll reduce to what? Pi over 6, good. Then 3/12 is pi over 4. 4/12 is pi over 3. And then we have 5/12, which doesn't reduce. We're just counting by 12ths. 1, 2, 3, 4, 5. 6/12 pi over 2. 7/12 does not reduce. 8/12 is 2/3. 9/12 is 3/4. 10/12 is 5/6. And then 11/12 doesn't reduce. And then what's 12/12? Pi, a whole pi. It's going to help for you to have this written at least once. We're just going to do it one time. I'm not going to label every single one of these, but we're just going to do it once, okay? So what's the next one? 13/12. 14/12 would be 7/6. 15/12 is 5/4. 16/12 is 4/3. 17/12 doesn't reduce. 18/12 is 3 pi over 2. And then 19/12. You're just filling out a unit circle with like a couple extra ones in there. 20/12 would be what? Five pi over 3, good. And then 7 pi over 4, and then 11 pi over 6, and then 23/12, and then 24/12 would be the whole way around, which was 2 pi. Actually, you can call it 0 pi or 2 pi. I usually call it 0 because that's where we start. Okay, we did that. Only took like a minute and a half. You all lived. It's good to have it written out once. I am not going to give you any of the 12ths. I'm not going to give you these ones because they're not on the unit circle. So if you want to cross those out, you can. I'm not going to give you those ones, okay? But now let's try and plot these. 2 comma pi over 3. You're going to rotate to pi over 3 and go 2 units away from the origin. So here's pi over 3, this line right here. And you're going to go 2 units away from the origin. So right there. And then just call that A. That's point A. All we're going to do is plot them. Did that go okay do you understand why that's there? Like that's all we're doing, all right? Here, we're gonna go backwards pi over 6 and then 3 units away from the origin. So if you go backwards pi over 6, that's gonna be right here, this line. And you're gonna go 3 units away from the origin. So 1, 2, 3, that's gonna be right here. Now for C, you're going to rotate 11 pi over 6 and then go 3 units away from the origin. Where's that going to put you? The same place as B. This point is both B and C. It's 2 different names for the exact same point. Cool, right? Neat. Love it. 5 comma pi, you're going to rotate to pi, which is right here, and go 5 units away from the origin. So that's going to put us right here. Now -5 pi, that means you're going to rotate to pi, but you're going to go 5 the opposite direction. So you would rotate to pi, but you're going to go 5 this way. So that's going to put you right here. Now I started a new grid for the other 5 because it starts to get cluttered once you put so many points on there. I'm not going to go around and label all of this one, but we did it once here so you can look back at it. But it's just the unit circle with a couple of extra lines on it. Right here, you're going to rotate to 2 pi over 3. What quadrant is that in? Quadrant 2. And then you're going to go 9 units away from the pole, okay, as we should call it. So that's this line right here, 2 pi over 3. And you're going to go 9 units away. All right, for G, we're going to rotate to 5 pi over 6. What quadrant is 5 pi over 6 in? 2, but we're going to go backwards 7. So what quadrant is that actually going to put you in? Like when you rotate, it would put you in 2, but when you go backwards, 4. Good. Okay, so if we go to 5 pi over 6, that's going to be this line right here. But you're going to go out the other side 7. So that's going to land us right here. All right, 3 pi over 2. Is that up, down, left, or right? It's down, and we're going to go 4 units away from the pole. So that will be right here. All right, here we're going to go 7 pi over 4. What quadrant would that be in? 4th, but we're going to go backwards 8. So it's actually going to end up in quadrant 2. Okay, so 7 pi over 4 would be right here. That's this line. But we're going to go backwards 8. So it'll take you out the other side into quadrant 2. And so that'll put us right here. All right, and then J, we're going to go to 7 pi over 6. What quadrant is that in? 7 pi over 6. 3, and then we're going to go 5 units away from the pole. So it's this line right here, and we're going to go 5 units away. So right there. Is this sitting well? Are we sort of okay? You rotate and then go that far away. If it's negative, you just go the opposite direction. Okay. On the back, I'm going to do these ones next, and then we'll do like a brain break and I'll show you how to convert them. But if they're on the axes, it's actually kind of easier to convert back and forth. So let's do these ones first. We're going to write these coordinates in both rectangular, and that just means what you've been used to your whole life, right? And then polar. Let's put them all in rectangular first. okay? What would be your point for A in rectangular, what you've been used to your whole life? 0, 8, that's it. And how about B? 0, -3, perfect. C is 6, 0. And then what is D? Yeah, do you see how like the 5 one and the 10 one are kind of bolded like a little bit? That like kind of helps a little bit. -7, 0. Now, if they're intercepts like that, it makes it easy because these are your quadrant angles like pi/2, pi, 3 pi/2, so on and so forth. All right, so how about A? How far did you rotate to get there? Pi/2, and again, weirdly, that's like the second part of the coordinate. I really wish it was first because you have to rotate first and then go how far. But anyway, again, no one asked me. And then we went how far in that direction? 8. So it's 8, pi/2. All right, for B, how far did we rotate? 3 pi/2, and we went 3 in that direction. So 3, 3 pi/2. C, how far did we rotate? 0 pi, nothing pi. And we went 6 in that direction. And then for D, how far did we go? Pi units, and we went 7 in that direction. But do you get that there are other possibilities for these? An infinite number of them. But I would try to keep everything positive if it's up to you. Okay, do like a little 5-minute brain break, and then I'll show you how to convert them back and forth. All right, so whenever you're converting from polar to rectangular or rectangular to polar, you want to think about this picture, which we have drawn in here before, but just go ahead and do it again. We're going to draw a right triangle. Here's our angle theta. Here's our x, here's our y, and then the hypotenuse is r. Because again, if you rotated the whole way around, it would form a circle, and r is your radius. And on the unit circle, r is always 1. Good. Now, these aren't all going to be on the unit circle. I was just checking. So if you want to convert from rectangular to polar, rectangular means you have x and y. You need r and theta. So if you have x and y, how could you get r? Knowing what you know about right triangles. If you have these two, how could you get that one? Yeah, good. It'll be Pythagorean theorem. X squared plus y squared equals r squared. And then you would solve it for r. So if you have x and y, but you need r, do Pythagorean theorem. All right, now pretend, take 2. I can't talk. It's Monday morning. Let me try again. Pretend you have x and y, but you need the angle. All right, so you're looking for the angle, but you have the opposite and the adjacent. How could you get that angle? Which one? Sine, cosine, or tangent, if you have these two. Tangent, because this is opposite and adjacent. Good. So tangent of theta equals y over x. And you would solve it, excuse me, for the angle. Now, pretend you have r and theta, you have these two, and you're trying to get these two. So you have the angle, and you have r, you have the hypotenuse. How could you get x? You have this and you have this. Which one? Cosine. Cosine of theta would equal what over what? Good, x over r, and then you would just solve for x. You would get x by itself. So if you multiply over the r just to try and get x by itself, x would equal r cosine theta. And then again, let's say you have polar, you're trying to get to rectangular. Oh my gosh, I cannot. You have r and theta, you're trying to get y. So you have these two, but you want y. Fine, good. Sine of theta equals opposite over hypotenuse. So y over r. And then again, you would just multiply the r over. So y equals r sine theta. So if you ever forget, because usually people will just memorize them, but if you ever forget, it's SOHCAHTOA, sine, cosine, tangent, just like in geometry class, and then the Pythagorean theorem. That's all that it is, okay? Now, I always draw a picture first because if it lands on one of the axes, you really don't have to do any work. Those ones you can kind of just do from looking at it. Okay, so you sort of avoid doing any work if it lands on the axes. You know, I'm gonna like throw you one of those. Okay, so just always draw it first, like just do a little sketch off to the side. So for example, 2 comma pi. If you rotate pi, where does that put you? Up, down, left, right. Where's pi? Left, and we went 2 in that direction. So that's where that point is. You don't have to do any work for this one. This is a no work question because what is that point in rectangular? Yeah, -2, 0. I'm not telling you to be lazy. I'm telling you to be efficient. If you don't have to do any work, don't. Now these other ones are going to have to actually look at. Okay. So again, I would draw a picture first though, just so you can see like what quadrant you're in. If you rotate pi over 4, what quadrant are you in? First, oh, but actually it's -1, so we're going to go backwards. So which quadrant is that going to put us in? 3, good. So you would rotate to pi over 4, but you go backwards 1. So that's going to put you kind of like right there. It's good to have an idea what quadrant you're in. I like a visual. I just always draw it. Okay. So if we want the rectangular form, we're going to use these right here. X equals r cosine theta. So r is -1, and then times cosine of pi over 4. So what is cosine of pi over 4? It's square root of 2 over 2, and then you multiply by -1, so negative square root of 2 over 2. So that's x. Now we need y. Y is r times sine of theta. So r is -1, and we're going to do sine of pi over 4. So hey guys, what's sine of pi over 4? Square root of 2 over 2, except we're going to make it negative. So y is also negative square root of 2 over 2. And so that's your point, x, y. And then you want to ask yourself, does that make sense? If you go left negative square root of 2 over 2, like left that much, and then down that much, would it put you right there, like where that point is? Does that make sense that they're both negative? Anyway. All right, let's try this one. X equals r cosine theta. R is 5. And we're going to multiply that by cosine of pi over 6. All right, so let's think about pi over 6. What goes across from pi over 6? 1/2, but cosine would be the x value, so that would be square root of 3 over 2. So this is 5 times square root of 3 over 2, which there's not really a whole lot we can do with that. Y equals r sine theta. So r is 5, and then sine pi over 6. So we actually already kind of answered that one. What was sine of pi over 6? 1/2, good. And so your coordinate point is x comma y. It'll be 5 square root of 3 over 2, comma 5/2. So again, x is r cosine theta, y is r sine theta. Keep calm and know the unit circle. Oh, I didn't draw that one though. I just said I like to draw them and then I didn't. I'm going to draw it. Pi over 6 would be like right here, and then you're going 5 in that direction. So that would put you like right about there. So then you can be like, oh, that makes sense. These are both positive. We're in the first quadrant. All right, now we have rectangular coordinates. We're going to convert them to polar. So let me draw this real quick. -1, 1. What quadrant would that point be in? 2. -1, 1 would put you right there. It's especially important to know what quadrant you're in when you're converting to polar, because you know how there's like a ton of different ways you can write it. You need to know what quadrant you're in. Are you guys okay? I know it's Monday morning. Are we just tired? Is that all? Okay. This isn't too bad, right? Okay. So now we're going to use these. We need r and we need theta. So first let's find r. It's going to be x squared plus y squared equals r squared. So that will be -1 squared plus 1 squared equals r squared. This is x and this is y. So it's just Pythagorean theorem. So what's that going to give us? This will be 1 plus 1 be 2, right? Equals r squared. And so what's r? Square root of 2. All right, and then we need the angle. We're going to use this right here. Tangent of theta equals y over x. So we're going to have tangent theta equals y over x. Okay, that would be 1 over -1, which would just be -1. That one's kind of tricky. What are the sides of the triangle when you end up with 1? Square root of 2 over 2, square root of 2 over 2. Now I need for it to be negative, and I need for it to be in the second quadrant. So how far did we rotate to get here? If I need for it to be the square root of 2 over 2 triangle and in the second quadrant. 3 pi over 4, good. So this is r, this is theta, and your point is r comma theta. So if we plot this one, 0, 5, this one's going to be a no work question. If it lands on the axes, like if you have an x or a y intercept, you can kind of just write the answer. How far did we rotate to get here? Pi over 2. And again, it's the second part of the coordinate. So pi over 2. And then we went 5 units in that direction. So 5 comma pi over 2. And then last one, if you go to graph that, 1 comma square root of 3. Well, square root of 3 would be somewhere between 1 and 2. So you'd be in the first quadrant. Again, it's good to know what quadrant you're in, especially when you're converting to polar form, because again, there's a lot of different ways you can rotate. So to get r, again, it's just Pythagorean theorem, x squared plus y squared equals r squared. So 1 squared plus square root of 3 squared equals r squared. You have to find r and you have to find theta. So 1 squared is just 1. What is this going to give us? 3. Good. So 1 plus 3 is 4. And so what's r? 2. Perfect. Oh my gosh, it came out to a nice whole number. How cool is that? And then to get theta, it's tangent of theta equals y over x. So that would be square root of 3 over 1, which would just be square root of 3. Now you kind of have to back that up a step. That would be square root of 3 over 2 over a half. And we need to be in the first quadrant. So what's our angle that will give us that? Pi over 3. And your point is r comma theta. So it's 2 comma pi over 3.